We are given the vector valued function r of t and asked to evaluate the definite integral from 1 to 3 of r of t dt. To do this, we integrate each of the three components from 1 to 3 with respect to t. And now let's consider the integral for the x component. We have the definite integral from 1 to 3 of 2 divided by the quantity t plus 1 dt. To help us recognize which integration formula to use, let's perform u substitution, where u is equal to the denominator of t plus 1, indicating du is equal to the derivative of t plus 1 times dt, giving us 1 dt or just dt. And now let's write the integral in terms of u, leaving off the limits of integration, because the limits of integration are t values, not u values. In terms of u, we would have the integral of 2 divided by u du, which we should recognize is equal to 2 natural log absolute value of u plus c, which means for the definite integral with respect to t, big F of t is equal to 2 natural log absolute value of t plus 1 rather than u. And of course, because we have a definite integral, we leave off the plus c. And now we determine big F of 3 minus big F of 1. For big F of 3, we have 2 times natural log absolute value of 4, which is just natural log 4. And then minus big F of 1, which gives us 2 natural log absolute value of 2, or 2 natural log 2. Let's go ahead and factor out the 2. We have 2 times the quantity natural log 4 minus natural log 2. This would be okay as a final result, but we can simplify further. Notice because we're subtracting two logs with the same base, we can apply the quotient property of logarithms, which states natural log 4 minus natural log 2 is equal to natural log of 4 divided by 2. Simplifying, we have 2 natural log 2. This indicates the integral from 1 to 3 of r of t dt is equal to a vector in which the x component is equal to 2 natural log 2. And just to verify this log property, let's check this on the calculator. Notice the calculator shows the first line and third line are equivalent. And now let's consider the integral for the y component. We have the integral from 1 to 3 of 2 e to the 3t dt. Again, because we don't have e to the t, we have e to the 3t. We need to perform u substitution, where u is equal to 3t, and therefore du is equal to 3 dt. Notice we have 2 dt, not 3 dt. Let's go ahead and solve this equation for dt by dividing both sides by 3, which indicates 1/3 du equals dt. And again, let's write the integral in terms of u. We still have the 2, and then dt is equal to 1/3 du. And e to the 3t is equal to e to the u, again because we let u equal 3t. Integrating, we have 2/3 e to the u plus c, which indicates for big F of t above, big F of t, the antiderivative, is equal to 2/3 e to the 3t. And now we find big F of 3 minus big F of 1 again. We could factor out the 2/3, but I'm going to go ahead and leave it as it is. Big F of 3 is equal to 2/3 times e to the power of 3 times 3, or e to the 9th, minus big F of 1 is equal to 2/3 times e to the power of 3 times 1, giving us e cubed. Let's go ahead and factor this. The greatest common factor is 2/3 e cubed, giving us 2/3 e cubed times the quantity e to the 6th minus 1. This is the y component of the vector. And now let's consider the integral for the z component. We have the integral from 1 to 3 of 2 times, let's write the cube root using the rational exponent of 1/3, giving us the quantity 4t minus 1 to the power of 1/3. Again, we need u substitution, where u is equal to the base of 4t minus 1. du is equal to the derivative of 4t minus 1 times dt, giving us 4 dt. Notice we have 2 dt, not 4 dt. We could divide both sides by 2 for a perfect match, but for consistency, I'm going to go and divide both sides by 4, indicating 1/4 du equals dt. In terms of u, we have 2, and then dt again is 1/4 du. And the quantity 4t minus 1 is u, giving us u to the 1/3. Integrating, well, 2/4 is 1/2. We have 1/2 times u to the power of 1/3 plus 1, that's 4/3. And then we divide by 4/3, which is equivalent to multiplying by the reciprocal of 3/4. Simplifying, we have 3/8 u to the 4/3 plus c, which indicates big F of t for the definite integral is 3/8 times the quantity 4t minus 1 to the 4/3. And we find big F of 3 minus big F of 1 one more time. We have 3/8 times, when t is 3, we have a base of 4 times 3 minus 1, which is 11, giving us 3/8 times 11 to the 4/3, minus, for big F of 1, we have 3/8 times, when t is 1, the base is 4 times 1 minus 1, which is 3, giving us 3/8 times 3 to the power of 4/3. Let's go ahead and factor out the 3/8, giving us 3/8 times 11 to the 4/3 minus 3 to the 4/3. This is a z component of the vector. The definite integral from 1 to 3 of the vector valued function r of t with respect to t is equal to the vector in which the x component is 2 natural log 2, the y component is 2/3 e to the 3rd times the quantity e to the 6th minus 1, and the z component is 3/8 times the quantity 11 to the 4/3 minus 3 to the 4/3. I hope you found this helpful.